This is section 5.2, part B, verifying trigonometric identities. So to start out this problem, if you notice, we have a cotangent on both pieces, and we have a secant on both pieces. So it is possible to factor those pieces out. If we factor out a cotangent and a secant, on the first part, if I divide cotangent secant cosecant squared by cotangent secant, the cotangent and the secant are going to be factored out. We're just going to be left with the cosecant squared. On the second part, if we factor out one cotangent, we're going to be left with cotangent squared. And if we factor out that secant, that'll just become 1, so that part is gone. Right now we have a cosecant squared and a cotangent squared. That's going to make me think of one of my Pythagorean identities. One of our Pythagorean identities is cotangent of theta plus 1 is equal to cosecant squared. So to take the cotangent to the other side, we're going to be left with cosecant squared of theta minus cotangent squared of theta is equal to 1. So we can come over here and we can replace this entire quantity with 1. So now we have cotangent of theta, secant of theta times 1. We multiply by 1. It's just going to be given the same value. But now we have cotangent and a secant, and we're trying to get down to cosecant. So let's go ahead and change these to sines and cosines. Cotangent, remember, is cosine over sine. Secant is 1 over cosine, because it's the reciprocal of cosine. If you notice, we have a cosine on top and a cosine on bottom. So if we multiply straight across, this is just going to be 1 over the sine of theta. And the reciprocal of sine is cosecant. It is sometimes helpful to work each side of an identity separately to obtain a common intermediate expression. So sometimes both sides don't look very pretty, so we can work on both sides at the same time and just try to make both sides look like the same thing. Okay, so on the left side we have a 1 plus secant x. We can't have any addition or subtraction in the denominator, so if we need to get rid of that addition, we're going to multiply by the conjugate. And remember, the conjugate is going to be 1 minus secant of x. So this is just going to leave me with tangent squared of x times 1 minus secant of x. All over, we are going to have to FOIL because we are multiplying two binomials. So first, outside, inside, and last. On the right side, if you notice, we have a fraction with just one value in the denominator, but we're doing addition or subtraction in the numerator, so we can break that into two different fractions. So I can say 1 over cosine of x minus cosine of x over cosine of x. Now let's go back to the left side. We have a secant x minus secant x, so those are going to cancel. So we're going to be left with tangent squared of x times 1 minus secant of x all over 1 minus secant squared of x. On the right side, 1 over cosine, the reciprocal of cosine is secant, and cosine over cosine will just reduce to be 1. So on the right side, we're probably done. That's as far as we can simplify over there. But we need to finish the left side so that it looks the same. Now in that denominator, I have 1 minus secant squared. That makes me think of one of my Pythagorean identities again. And we have the Pythagorean identity that says the tangent squared of x plus 1 is equal to the secant squared of x. If I take that 1 to the other side, we know that the tangent squared of x is equal to the secant squared of x minus 1. But if we look over there, that's not the same order. We need to switch the values. So if we multiply everything over here by a negative 1, then we're going to be left with negative tangent squared of x is equal to negative secant squared of x plus 1. Or we can rearrange this and say 1 minus secant squared of x. So we can replace this 1 minus secant squared with a negative tangent squared. Now we have a tangent squared on top and we have a tangent squared on bottom. So these are going to cancel. We are left with that negative 1. So when we cancel this tangent over here, you are left with this negative 1. So we can bring that negative 1 out front over here. And if we distribute that, negative 1 times 1 gives me negative 1. Negative 1 times negative secant gives me a positive secant. And if we rearrange this, this gives me the secant of x minus 1 is equal to the secant of x minus 1. So when we summarize what we're doing with we're verifying trigonometric identities, you're going to start with the more complicated side of the identity and work it until it's simpler side, keeping the other side of the identity in mind as your goal. Use reciprocal, quotient, Pythagorean, and other basic trigonometric identities. You can use your algebraic operations, such as combining fractions, rewriting fractions as sum or differences, multiplying expressions, or factoring expressions. We can convert a denominator of the form of 1 plus or minus u or u 1 plus or minus 1 to a single term using its conjugate and then a Pythagorean identity. We're allowed to work each side separately to reach a common expression. And if no other strategy presents itself, try converting the entire expression to one function or just in sines and cosines.